Hello everyone guys and welcome to the stream. So in the next 1 hour or so, what we are going to do today is we're going to learn how to build a CorDapp. So we'll build a CorDapp, we'll try to deploy the CorDapp in front of you guys, and it's very much possible then you could also do it with us. We'll share you with a link of the IDE, and then by the end of the session we'll be able to have a running CorDapp with us. So my name is Ashutosh, and I'm joined by Sneha. Both of us are part of developer relations. We are developer evangelists. We're based out in Mumbai, and thank you all for joining this session. We're really excited to have you all today. So without much further delay, let me just share my screen. All right. So there you go. So before we start, let me just do a little bit of an energy check for everyone. It's just like 2 p.m. here in India, and we're just out of our lunch. So let's just do an energy check. How are you guys feeling? How is your energy? Just write it out on the chat, and let's have some fun. Is it high? Is it medium? Is it low? Just let us know. And just that so that you guys are aware, by the time you listen to me, it will be like 30 seconds because there is a little bit of a delay between the time I speak and the time it reaches you on the stream. So till that time, let me just do some of the other stuff. Let me try to make sure that you know where to go when you start your development. So few things that are uh, that you should remember is you're developing and you are having certain issues. Where do you go? The best thing is to join the Corda Ledger Slack, which is a community of almost 700, almost 8,500 plus Corda developers. And we also have people from R3 in there. So you have any issues, just join Corda Slack and put your question, talk to people around there. You could also look at the documentation. If you're one of those guys who sort of likes to know what's happening inside the background, and you want to see what's there in Corda. So anything and everything that you want to know about Corda is in the documentation. So go to docs.corda.net. And the next thing is pretty a little bit more interesting, is the free training site. So this is something which we just launched around a month or so, just few weeks, I would say. And there are a few guys who like to learn things in a streamlined way, right? You want to start from the beginning and you want to end the end. You want that kind of a storyline there. So this is the place where you would go. Just go there. It starts with something like learning what is blockchain, and then you learn through. You have a complete journey there. You learn what different things of Corda are in increasing complexities, and at the end you'll have a very good understanding of what Corda is and how to work around there, how to build applications on top of Corda as well. You want to look a code of Corda, the platform itself, go to github.com/Corda. Corda is open source, so you have all the code in there, and you could just go there and check out the code. So we are developers, we love looking at code, so do feel free to look at what the platform is doing in the background. You want to contact us, the Devrel team, just go to or probably email us at devrel@r3.com. That's a group DL, so it will be answered by someone from the R3 developer relations team. So tweet us. Our official handles are Corda blockchain for Corda and inside R3 for R3. And do not forget to use #Corda and #R3 as the hashtags. All right, so with that, we will just go ahead and start with our session today. All right, yeah. So before we just move into coding, there isn't much slides here. This is the only thing that I'm going to talk to you guys about by looking at slides is we'll just do a brief refresh of what we have learned in the previous session or the previous stream where we talked about Corda in details. And in this session, it's more of a hands-on one. We'll immediately concentrate on writing CorDapps. But before that, it's been a week or so, and our memories need some sort of reinforcement, right? So let's just do that. Let's just learn from a CorDapp perspective. Let's just learn what is required to develop a CorDapp. So first of all, the question, what is a CorDapp? We talked about this in the previous stream, and if you're not part of that stream, you haven't seen that. It's the recording is available on the channel, so feel free to look at that after this stream. But I'll just give you a brief on what are the different components of CorDapp that we will be developing today. So what is a CorDapp? First of all, it's actually an application. CorDapp stands for Corda Decentralized Application. And there's something like an application which runs on Corda. It's analogous to something like Android, and then you find applications of Android on the Google Play Store, right? So if you compare it with Corda, then if Android the Android thing that the OS itself is Corda, and then the applications that you run on Corda on Android and could be related to something like a CorDapp. So it's more like that sort of a relationship. So you have Corda as a platform, and then you would develop CorDapps which run on the Corda platform. So three things to understand here when we start working on a CorDapp. These three things are states, contracts, and flows. So what are these things? These three things. The first thing, state. So when you talk of blockchain, you want to store some assets on the blockchain, right? And the way you store them in Corda is by creating a state. So a state is a representation of an asset or any facts that you really want to store on Corda. It gets created, it gets consumed, it gets updated, which we'll talk about later on. And then once you have your asset on the ledger, how do you update those ledgers? These assets are going to be sort of going to change over time, right? But you know that anything that's put on a blockchain is immutable. So Corda is no different than that. Any state you put on the Corda ledger becomes immutable. You cannot really change them. So how do you really change? Is you don't really change what's there, but you just update it. You create a new thing, just put your updates, and then you just put it on the ledger, mark the previous one as consumed or historic, which means you cannot really use that previous one anymore. But the most recent one is the one which you have just updated and you have just put that on the ledger. But this update, you can't just put any update that you want. There has to be certain rules that you need to follow, right? These could be something like business rules which you want to follow. These business rules, they come inside the contract. So every state is associated with a contract which will govern its evolution over time, and that contract will say what are the different rules that you want to follow when you do a particular update on an asset. And we are going to develop the state, the contract, and as well as the flow, which I'll talk about just in a minute. So just a bit of digging deeper into the contract. So when I say every state is sort of associated with a single contract, but the contract says what are the different rules that you need to follow to perform an update on the asset. So an update is something like you're doing a certain action, right? So for example, if you're having a vehicle which is on your ledger, and then you're doing a registration of that vehicle, so that is an action. So there are certain rules that you would follow in order to do that action. But there could be multiple actions, right? It's not just the registration of the vehicle that you do, but other things could be something around, let's say, other than registration, you do insurance, you do surveys, or you're probably reselling the vehicle. So all are different actions and all requires different set of rules, right? So how do you accommodate that? So to do that, we have something called commands, which you could see on this diagram. There is this red arrow which says transfer, right? That's a sort of a command which we put when we do a transaction. So every command, it relates to the action that you're performing, or the intent of the transaction, I would say. So that's contracts. So contracts are rules, and then these would have commands which are basically your intent, or the commands basically tell you what are the different rules that you want to follow. If there is an action that has to be performed, which part of the contract has to be run, that is defined by the commands. And the last component which is required to develop a CorDapp is the flow, right? So what is exactly a flow, right? We talked about asset, we talked about the rules that we want to have when we basically want to update anything on the asset. But when you do an update, any business in any business scenarios, there are often something called business processes, right? You have certain different steps that needs to be followed in a sequential manner in order to do a particular business, in order to do a particular action in any business, or any particular action in a business use case, right? So these different flows, or these different, I would say, the workflows could be modeled using the flows. The flows is a very, very powerful framework in Corda, which you could utilize to model very, very complex workflows in your business scenarios. We'll talk about very simple flows in this one. We're not going too deep into the complexities of flows, but yeah, once you have the basic understanding of how it works, we will give you a sort of a very simple two-party trade flow, and then you could basically take that information that we provide you by the means of writing a simple flow, and then you could probably use that information which you gain into your own use cases while you develop your own code apps. All right, that's pretty much from the slides point of view. I just wanted to give you a brief on what we discussed um, in the previous stream. So let's move on to coding. No more slides. We don't like slides, right? So let's move on to coding. All right. So we are not doing a local setup. We are not doing. We're not firing up an IDE or something on our local system. But what we will be doing is we're using this online IDE, and you could actually access it at ide.corda.net. I'll put that on the chat. There you go. That's ide.corda.net. All right. Um, So just do not copy this part. This is my own my own version or my own instance of the IDE. You will be assigned a different one. So just type in ide.corda.net if you want to continue doing the coding with me. Otherwise, you can just follow along. And there is also a solutions.md in here, which you could utilize after the session if you're not able to follow along, or probably you are facing some issues somewhere. So we have the solutions in here for you. Just go there, copy paste, and try to run the application. Try to see what's going wrong with your code. So let's just get started. I'll just talk to you in a brief about what's here on the online IDE and why we are using this. Well, the local setup requires you to have certain softwares like Java, installed a particular version of Java, and then you need to have the IntelliJ IDEA and then import the project properly, which is not very difficult to do, but still it requires some time if you don't have if you don't have Java installed on your machine, or you don't have IntelliJ IDEA on your machine. You need to do that setup on your, which takes time, but it's not really feasible for us to get your local setup done. So we have something called the online IDE, which comes pre-installed with all these things. So you just type in ide.corda.net basically, and then you get this Visual Studio Code IDE on your browsers. And it comes preloaded with this particular CorDapp, which is the Bootcamp CorDapp. And if you want to just look at, or you want to download this on your local, so what you could do is this is your, I'll just ping it on the chat again. There you go. So just go to that link. This is this is basically your GitHub, where you find this particular CorDapp, Bootcamp CorDapp, which has been downloaded in here. So you want to do this on local, just go there, download it. But I would highly recommend, at least for now, just go with the online IDE. It would be a lot easier to follow up. All right. So just looking at the folder structure here, what we have here is the source folder where you have your code. The way we are going to do this today is we're going to do a token use case. So what we're going to do is we are going to create a token, and we're going to issue that token to so there will be two parties, an issuer and then a holder, or an owner who will be owning that token. The issuer will issue some tokens onto the holder, and they'll be able to view those tokens on their nodes. So we will fire a small network where we will have this CorDapp deployed, and at the end of it, we will try to run some transactions and see how things work in Corda. Well, so the way we're going to do is we are following the TDD approach, which is test-driven development. If you go to the test folder, we have certain test files here, which are state test, flow test, contract test, pretty self-explanatory. We need to develop 3 different components for the CorDapp, which is the state, the contract, and the flow, which we talked about. So all these 3 tests are basically the tests for all these 3 different components. Sorry. And if you have, so we'll start with the states, and if you go to state test, these all tests are commented out. The first thing we'll do is uncomment these tests, and then we will write the corresponding code onto the token state, which is over here. Then if you see that all your test cases have passed successfully, which means that you have written your token contract or your token state correctly, and then you're ready to move on to the next component, which is the contract. So let's start with the state. While I write each and every piece of code over here, I'll just try to explain whatever I'm doing, right? So that we are able to relate to what we learned in our slides. Okay, so let me just select all of these and then uncomment them. So to uncomment, you could use command / or control / depending on your operating system. All right. So there are certain issues with this. You would see this red underlines, which is more like compilation issues. That's because we haven't yet implemented our token state. So don't worry about that. As and when we we write our different we write our code on the token state, these compilation errors are going to go away. So when I go to state, we want to develop a token. So what are the different things that we could have on the token? The different things that comes to my mind is first thing that comes to my mind is we talked about issuer and owner, right? So there has to be an issuer and there has to be an owner. Someone has to issue the token, someone has to hold the token. So what do we do? So we need 2 different fields on the token state. What would that be? That would be the issuer and the owner. So there are different APIs available in Corda. So when I say issuer and owner, you just try to understand that these are 2 different nodes or 2 different identities on the Corda network, right? So how do you represent an identity? There has to be a data type for that. What is the particular data type that I use when I want to represent an identity? So for that, we use something called as a party. So it's available on Corda. So just use public party and then let's say issuer. So to use to represent an identity, we use the class party, right? So that would have so party is something like, if I just go in here to the class, what it has is it has certain certificates. It has an x50 x500 name, which has it's something like it has your name, what is your legal name, what is your location that you're located now. These are sort of standards that we generally use. And then you have a public key, which is used to identify you, just like any other blockchain systems, right? There are public and private key pairs which are used to do transactions. Public key is something that that is used to represent you, or you are identified by a public key on the network. And then you have the private key, which you use to sign transactions. So it is no different here. We have a key pair for each identities. So that's a party. So that's how you use, if you want to represent an entity in Corda, use the party class. And then we talked about issuer. Now we need to have the owner, right? Who is the holder of the token. So whenever you issue this token, it needs to be owned by a particular identity. So that's party again, right? The third thing that we need, just try and keep it to bare minimum. Right, can we have the, so here you go. Sorry about that. I just forgot to make this thing a bit larger, but yeah. There you go. So the third thing that I'm going to put here, trying to keep it bare minimum. So it's just a sort of a beginner tutorial for you guys. So we won't have too many different facts that we will track over here. So one more thing that I would probably want to have is an amount. So when I'm going to issue a token, I want to issue a token of a certain amount. I don't want to have a token without an amount. That's not going to be very useful, right? A zero amount token, what would I do with that? So let's put an amount, and it's pretty much easy to put an amount. Let's not worry about the floating points and all. Let's keep it simple. So keeping it the data type as just integer, and there we go, amount, right? So these are the three things that we need to have on our, so there could be other things like whichever you want to track onto your on this token asset, but for me, for this exercise, this is pretty much enough. All right, now in order for Corda to understand that this particular class that I'm writing is actually a state, I need to implement a particular interface which is called as contract state. There you go. And that's it. This makes it a state in Corda. Now, as I implement the contract state, I get a little bit of an error which asks me to implement or override a particular method called get participants. So I will just hover over here, and then that will give me this little bit of a thing called quick fix. And on clicking on that, it will auto generate your get participant method for me. Not much typing for me. So if you are a lazy developer like me, just make use of the shortcuts. All right. So there you go. We have something called get participants. Now what do we do with this? We learned that with Corda, whenever you do a transaction, it's more or less point to point. It's not like we don't do a global broadcast. So whenever you do a transaction with two parties, the data about that transaction or whatever asset you're transacting is only available with those parties who are involved in a transaction. Now, when we say this particular fact, how does Corda knows which are the different parties that should know about a particular state? Now, taking the example of token state, I don't want if there are 10 different participants in a Corda network, and I'm issuing a particular token. I'm a party A, and there is a party B. And if I'm issuing that token to party B as party A, I don't want that other parties like party X, party Y, party Z, all these guys who are in the network get to know that what's happening. I'm issuing a token to party B. So for that, Corda takes care of that. But so whenever there is a transaction, it is private between the parties who are involved. And in order for Corda to be able to do that, we need to tell on the state that who are the parties that should be aware of this particular state. So this is where we return a list of parties who should be aware about this state. So for me, who are the parties that should be aware of this state? So for me, they are the issuer and the owner. All right. So I will just return an array, and I would say issuer and owner. There you go. So this is not the class I want. I want the java.utils. All right. Okay, so there you go. Now I am returning the issuer and the owner from my class, which means Corda now knows that whenever this state is transacted, who are the parties that should know about this state. So it's the issuer and the owner. Others, we don't care about them. We are not involved. They are not involved in the transaction, so they won't get to know what's happening. Right, what are the next things that we want to do is we need a constructor just like any normal Pojo class. And you could, just like I said, I'm not a fan of typing. So I will just generate them, just right click, go to source action and generate constructor. Right click, just click on all of them, and that will generate a constructor for me with all those um, different fields that I have as parameters. All right, so what next? I need to have some getters. Rather, what do I? This is a mistake. Let's make it private. We don't really have public fields in Java. All right, this is just proper programming practice. All right, so to access them now, what we need is getters, right? Again, we will just generate them, right click, source action, getters and setters, just click them and enter. And there you go, all your getters and setters have been generated, but I don't really need the setters. You can just leave it as such, but I don't like to have them because anyways, these are immutable and you're not going to use them ever. So why not just delete them, right? All right, so just the getters, and that's pretty much it. I think we are done with our state. Isn't that difficult, right? So just to create a state, all you have to do is you just have to create sort of a Pojo class and then put in all your fields that you want to track on the state and implement the contract state interface. That's the most important thing, so that Corda knows that this is actually a state, a Corda state that you're trying to develop. And that would require you to override your get participants method, and you need to return all the participants or the parties who should be aware of the state. All right, so I've written all of these, and I need to make sure that whatever I've done here is actually correct, right? So what I would do is go to the state test and see, we had these errors which have now gone because we have implemented the token state class, and I could just run the test cases. So if you want to run the entire test cases, I mean all the test cases that are written over here in the class, you can run the class level thing here. There's the class level little button here which says run test or debug test, and there are also each method level things here, little buttons which says run the test. So this will run only this particular test, and this will run all the tests that are there in class. So since we have written down the entire class, so let's just run it from the class level so that we are able to see if we are able to pass all the different test cases that have been written for the states. And you get to see this little sort of symbol here with X or with a cross and a 0 and a tick and a 4, which sort of indicates what are the number of test cases which have passed and what are the number of test cases which have failed. And if you just click on that, you get this little bit of a report which says what are the tests that you have run and whether they have passed or failed. So all the 4 tests have passed, and we are good with our state. So congratulations, everyone. We are done with the state. We have successfully developed our first Corda state. All right, so just a little bit of some more information which I forgot to mention is we have this simple folder here called examples. These are already coded. If you just go there, this have been implemented, and this is more for a reference purpose. And if you're doing it on your own, you want to see how things are written, just go there, refer to these things. They have things already implemented, and they might help you a lot when you want to develop it on your own. So the examples are more for reference for you guys. We are not touching it in this particular stream anyways. But yeah, that's it. We're done with our state. All right, so next thing that we want to do is the contract. Next thing is we will develop this particular thing called the token contract. We don't have anything here. It's completely empty. But we are going to write all these things, and we're going to uncomment the entire, so a lot of test cases here in the contracts, and we're going to write the contracts now. Before that, before I start with the contract, let's just do a little bit of a poll. How did you felt about writing the state? Was it easy? Was it difficult? What do you feel about it? Just put it on the comment. Just put it on the live chat. I will just look at that later on while my words reach you. That's going to take some time, like I said. But till that time, I will just try and explain what we're going to do here in the contract. All right. So again, we are doing the same thing. We will just go ahead and try and uncomment each and every test cases one after the other, and then it will write down all the different code that is required to get your test cases running. Right. I'll try to make it as simple as possible. Thank you for commenting over there or putting your comments. Someone said it's easy. Well, thank you very much. I guess it's not that difficult. It's more like just putting in writing a simple Java project class, right? States are simple. Okay, so time to write our contracts. Let's see if it's as easy as the states or is it a little bit more complicated. Well, to write a contract just like we wrote states, now the first thing that we have to do is let Corda know that we are writing a contract. And how do we do that? We just have to implement something, some particular interface. That interface is called simply the contract interface. For writing a contract, we implement the contract interface. Okay, if this is not written anyways, you have a simple class, then it will tell you um, to override a particular method, which is called as the verify method. And there you go, that's your verify method. Just rename this to make it more sense. Right, it was the same thing which I actually deleted. So show you guys that you can, this is what you need to do when you implement a contract interface onto an empty class. All right. So what does this method gives me? We talked about this when we talked a little bit about contract, right? We said that we are going to have to write all our business logic, right? We're going to have to write all our business rules when we want to make sure that we are actually doing a change onto the state. So we want to have the rules written over here. Those rules go inside the verify method. That's why we have to override the verify method when you implement the contract interface, right? And what you get inside the verify method is actually a transaction object. So whenever, like I said, whenever you do update to your state, you need to do it via the means of a transaction, right? So that transaction object is entirely dumped into your verify method so that you get to know what was the previous state of your asset and what's the new state of the asset, what is the change that people are trying to do. And then you could have your logic to verify, to validate whether this change is actually legit or not, right? So that was this is done. Let's go back to our contract test. Yeah. So I'll just uncomment the first one, which is pretty much simple. Again, to uncomment, command / or control / depending on your machine or Windows or Linux, basically. But yeah, the first test case is pretty simple. We already did this. It just want us to implement the contract interface, right? Things become a little sort of different when we try to see the other test cases. Let's put this down a little bit. Uh, Here we go. I'll just uncomment this. Now this doesn't look like a regular JUnit, right? This is a little bit more involved than a regular JUnit test case. Why is that? Well, that's because we have our own contract DSL language to make contract testing easier. The contracts are run on Corda nodes, and you need a transaction to basically simulate a contract and try and see how it's going to behave when you're trying to test that. You're trying to unit test, do a unit test on that particular contract. Sorry. So, so the DSL helps you. DSL is actually going to create mock services, which is over here. You see mock services, and then you could also have test identities, like we have the issuer and the owner, so we need to include them in our tests as well. So unless we have a node, how do we have them? So we could create even test identities with a DSL, and then we could have mock services which we could use to create mock transactions as well, right? So what we are trying to do in this test case, I just explained one of them, and then others will be pretty much simple to you guys. Right. So the first test case, what we're trying to do is we are running two different transactions. So if you see this and this, they are two transactions which we are trying to run. So the first transaction says, the entire test case says that the token contract requires zero input in the transaction. Why does it require zero input? First case, because we are doing an issuance transaction, and every transaction has an input and it has an output. So the input is the thing that you're trying to consume in your transaction, and the output is the updated asset which you're trying to produce. So if you want to do a change of ownership, for example, you are trying to bring in a state, you are trying to pull in a state out of ledger, and then you're updating that state, and then you are trying to um, do a transaction. So when you do this, what happens is you would have certain inputs, you have certain amount output, and then you would also have certain commands like which says what's the intent of your transaction is. And this transaction says zero input because it's an issuance. There is nothing that existed in the ledger at this point of time. The token is being put in the ledger for the very first time, so there's nothing to consume. It's an issuance, so you should not have an input, right? So here we are actually putting an input and we assume that the transaction should fail. While here, over here in the next one, we are not having any input and we assume that the transaction would pass because that's what we're trying to test, right? So two transactions, one is testing the positive case, the other is testing the negative case. And if this first transaction fails and the second transaction passes, which is what we are expecting, only then the entire test case would pass, right? So that's how we are doing the entire all the different test cases as well. We're doing different transactions, some for positive cases, some for negative cases, and then make sure that um, we the test case behaves in the way that the transactions should. If the transactions who are supposed to pass passes and the transaction was supposed to fail, only then the entire test case would pass or fail depending on that. All right, so time to write our contract. What is the first contract is it says we want zero inputs in the transaction. So we have the tx object, and if you just say get inputs, you get all the inputs, and this is actually a list of all the inputs, and then you could say size is not equal to 0. We are actually testing for 0, so we'll give not loss. We need to throw an exception. So whenever the contract actually runs without an exception, we say that the contract has validated, and if the contract has any errors or something, then it should throw an exception out of it. So in this case, we need to throw an exception. If we see that it's not equal to 0, so it has some inputs. In that case, that it's not what we expected, so we need to just throw an exception. So new, and what's the exception? It's the illegal argument exception. Remember, it's always the illegal argument exception that we throw because it's the platform which has to catch it and behave accordingly. So the platform will catch the illegal argument exception. You can just pass in a simple message which would say what's going wrong. You could say 0 inputs expected. Right. Then let me just test this thing before we move on to see everything is fine. Right. You could see that the test is running over here. That should be done in a minute. Right, the test case has passed. You could say, you could validate with that with a tick and a 1 because we just ran one test case and it indicates that that particular test case has passed. Okay, so moving on to the next test case, which says, so I'll just do the next two test cases together, which is pretty much simple or similar as well. The next one says that the number of output should be 1, the number of command should be 1, right? Why the number of output should be 1 is because we don't want to accidentally issue something else while we are trying to issue tokens. So we need to validate that we have exactly one output. Get output states dot size, pretty much similar to what we did earlier. This time we are checking for 1 is not equal to 1, and then just the similar thing, throw an exception if that doesn't, if that's not the case, say 1, output expected. All right, next thing is to check for commands. We want to validate what the command is. So generally this is not required. You would have more than multiple commands, but just as a demonstration. So what we would really do is check what the command is and write your validation cases according to that. But just as a demonstration, I can do, I'm going to show you how to get the command and validate what the command is, right? So again, it's pretty simple. Get commands will give you a list of commands, and then you tell what's the size. It's not equal to 1 again. I can just throw this exception. And the message will be 1 command expected this time. All right, so we are done with these 3 test cases, and let's move on to the other one. And before I do that, let me just run it from the class level and see that everything that I have written is working fine till this moment. There's a lot of test cases. I just want to make sure that I'm not making any mistakes while I go. So we should get 3 test cases passed, or 4. All right, 4 test cases have passed, so no mistakes till now. Next one. This says the token contract requires the output to be a token state. Now, till now, what we have been doing is sort of looking at the shape of the transaction, number of inputs, number of outputs. Now we are getting into the content of the transaction. What's the type of? So we now know that we have something in the output, but is that really a token? So we just need to check that what we are getting is a token. So tx.get output. If you see, I have this particular method which takes an index. I already know there is output, so I can use that without any problem. And I just need to check that it's of type token state. If that's not, then I'm going to throw an exception. So do not forget to put the not clause. It's pretty easy to forget that. And a proper message saying token state expected, right? And just running this test case again to validate that's right what I wrote. While that runs, let's just see what the next test case says. Just uncomment this entire thing. The test case has passed, so our code was correct. And this is where we test the amount. So we don't want the amount to be like 0. We want it to be more than 0, or we want it to be positive. So the token of 0 amount is just useless. So why do we even allow something like that? So let's just say, but the amount is something which is, I need an instance of token state, because that's where I have defined the amount. If I get the tx.get output, if you see, it is not exactly a token state which is written from here. It returns a contract state. So I need to do a little bit of a typecasting here to get that. I will say token state equals, there you go. And then now I can get hold of the amount. State dot amount is less than 0, then I need to throw an error again. Do not forget the not clause. Go. positive amount expected. That should be it. Again, let's just try and test that. While that runs, we will take care of the next test case, which says that it requires a issue command, right? I'll let the test case run before we actually see what's going on. Oh, the test case has failed. Why did it fail? It's because, okay, did not get an exception. What's going wrong here? Okay, I need to be less than equal to 0. We are not expecting 0 as well. All right, a little bit of a mistake there. And this is why I want to run each and every test case so that we get to know what's going wrong. Otherwise, you'll be wondering at the end what went wrong, and then it could get really difficult to sort of try and see, still doesn't work. Okay, am I running the right test case? It is. All right. Count. Let's try the different way. The contract date needs to be positive. All right. So yeah, a little bit of a mistake. I was just doing the other way around, but yeah, that works. The last thing, just a little bit of confusion about positive and negative, but yeah, that works now. So the next thing is about our token, the command. So it should be the issue command, right? And I just again need to get the token state, or basically the command has to be taken from the transaction, and my command needs to be of type issue. So to get the issue command, I need to do something called get value, which is where I get the type of the command. To get value would give me the type, and it needs to be issue dot So it's command dot issue. There you go. Again, just putting in the not clause here. Right. And then the last thing is the exception, which should say issue command expected. Time to test this out. Run the test. And while that runs, let's just uncomment our last piece, which is about the signers. So the last one is where we will test who the signers are for our transaction. As you could see, the last case has also, the previous test case has passed, so the issue one is correct. And this is the last test case where we just check who our signers should be. For this issuance, we want the issuer to sign. We just need to validate that the transaction has the signature of the issuer. And how do we do that? So command contains two things. The one is the signers and the other is the type of the command. Now the signers are the guys who should actually sign the transaction for the transaction to be valid. So we could say get tx.get commands at index 0 and get signers, which is a list of public key. If you could see this here, get signers is a list of public key. And what I need now is I need to check whether this contains the public key of the issuer. So where do I get the issuer? I've mentioned the issuer on the token class or the token state class. So I can just get the issuer. That's a party. I also showed the party class. It has the public key. So I I use the get owning key to get its public key. If it doesn't contain that, then it's going to be a problem. So we need to throw an exception, which is somewhat like this. And finally, we just say issuer signature required. That's it. I guess this should be it for our last test case. All right, so test case has also passed. So that's it. I think we have passed all our test cases. Just let's make sure we are running it from from the class level to make sure that all our test cases are also passing when we try and run them together. All right, so while they run, this is what is going to happen. We should get 8 or 9 test cases which have passed. So should be done in a minute now. All right, we have all the test cases which have passed. So currently we are done with our state and we're done with our contract. The only thing that's remaining for us to do is the flow. So for that, I'll pass it on to Sneha, and Sneha will take care of you guys and she will try to show you how to develop a flow, as well as she'll try to show you how to deploy this entire application, try to run transactions on that. Thank you very much. Over to you, Sneha.
Thank you, Ashutosh. Let me quickly share my screen. Yeah. So can you guys see my screen? Cool. So, so quickly, just to summarize what all things we did till now, we saw what the state is, we saw what a contract is. We saw that how the shared facts become a part, will go as a part of a state. We also saw that um, how a ledger evolves using states, and we also saw that how all the rules or the business constraint will go as a part of the contract. Now, the last part which we are going to do now is writing the flow. Now, flow, in a way, you can say that a flow is basically a flow. You can say it is a set of business, your business logic, your entire business logic will go as a part of the flow. Now, what we're doing is today's we are building a small Corda app, right? We are building a token issuance Corda app. So what we are really interested is we are going to issue a token from one party to the other party. Now, this to issue a particular token from one party to the other party, all these or whatever steps are required for issuing a token from one party to the other party will go as a part of the flow. Now, there are two parts to the flow. One is the token issuance flow, and one is the token issuance flow initiator and the responder. Today, we are going to only look at the initiator. Responder is already implemented for you. So what we're going to do is we are going to basically issue a token from party A to party B. So we are going to write the entire logic required for tokens issuance in this token issuance flow initiator flow. Once we write this flow, what we're going to do is we're going to deploy a Corda network locally. We all of us are going to deploy it together. And then we are going to fire this flow, which is the token issue flow initiator from party A side. So once we fire this flow from party A side, party A is going to issue a token from party A to party B. Okay. So let's understand what are the series of steps which are required to basically issue a token from one party to the other party. Now, the very first step which is required for, I would say, to basically issue a token or issue a token state from one party to the other party is what will happen is party A, the very first time party A will create a transaction. Now, as Ashutosh mentioned, a transaction in Corda is a proposal to update the ledger. So what is party A trying to propose? Party A is trying to propose that party A wants to issue a token from party A to party B. So this is the proposal which party A will make. So this proposal, or rather this transaction, we will build it in this particular flow. Okay. So the very first thing is we will build the transaction. Once we build the transaction, you would have to add, or you will have to define, or you'll have to add what exactly you're trying to do in this proposal. So what party A will do is party A will create a state called as token state. And what we'll do is we'll add this token state as an output state to this particular transaction. So basically what we'll do is we'll basically create an issuance transaction. So when we create an issuance transaction, what we mean by that is this issuance transaction, it will have 0 inputs and it will have 1 output. This 1 output is nothing but it will be a new token state which party A will issue from party A to party B. Okay. So the very first thing is create the transaction, that is create the proposal. So party A will create the proposal, party A will create a token state, and party A will add the token state to this particular proposal, to this particular transaction. Once this proposal is done, party A should also specify what the intent of this particular transaction is. So what party A will do is, party A will say that the intent of my transaction is an issuance transaction, or rather it will say that I want to issue a token. So we will also specify this intent as a part of the command in the particular transaction. And also we will also specify the signers which are required to execute or which are associated to sign for this particular token issuance. So 3 things we saw till now: create the transaction, that is create the proposal, add the token state as an output state, and the third thing is define the intent and the signers of this particular transaction. So once we create our temporary transaction, what party A will do is party A will run the contract which you guys just wrote, right? Right now you just wrote a contract, and for the contract, what you saw was, for the contract you had the transaction as an input to the verify method. And what we did was we ran the entire transaction against a set of rules. So we are going to do the same thing once we build this particular transaction. Once party A builds this particular proposal, party A will simply call the verify method. That is the set of rules and which you guys have defined in the contract will be run against this particular transaction. And if there's no exception thrown from within the contract, you can safely say that basically the transaction is valid because it satisfies all the contract rules. Once party A is satisfied that it has run the contract and nothing fails, then what it will do is it will initiate a session with the counterparty. So it will also initiate a session with let's say party B. And before doing that, what party A will do is party A will itself sign this particular transaction. So basically, first party A will create the transaction proposal. He will himself verify the contract. He will himself verify whether the transaction is valid by running the contract. And once he does that, if he is happy, if all the contract rules pass, he will sign this particular transaction. Once he signs this particular transaction, he will send this particular partially signed transaction to the counterparty. So this particular partially signed transaction will be sent to party B. And party B, after receiving this particular partially signed transaction, party B will also do similar things. It will look at the transaction proposal and it will also run the contract on its side. So the same set of rules will be applied on party B side as well. And if party B also thinks that if party B is happy and if all the contract rules pass, then party B will also sign the transaction. And then party B will send this particular signed transaction to party A again. So as of now, party A will have a completely signed transaction signed by party A as well as signed by party B, verified by party A as well as verified by party B. Both have run the contract on their side. The contract has passed on both the sides, and then both of them have signed this particular transaction. So in Corda, to actually sign a particular transaction, we just call something called a sign initial transaction, which takes care of signing a particular transaction. Similarly, for party A to send the particular transaction to the counterparties or to party B, and then wait and collect for their signatures, you have something called as the collect signature flow. So there are a lot of inbuilt flows which can easily be used in your flow. So you don't really have to write the entire logic of first taking the transaction, sending it to the counterparties, waiting for their response, and making sure that they sign the transaction. So all of this is automated because of these kind of flows given to you. So once the party B signs the transaction and sends it back to party A, we'll call one more flow, which is the finality flow, which basically what it does is it checks for double spend. It checks that whether party A is trying to be dishonest, and it checks whether party A is trying to send this same token to two counterparties at the same time. So this is what double spend is. That is trying to spend a particular state at the same time. So it'll just check whether it's double spend or not. And if not, the notary, which basically handles double spend in Corda, it'll also sign the transaction, and then with finality flow, both the counterparties, that is party A and party B, will receive a copy of the token state. So this is going to be our entire flow, which we are going to do today. On the token flow responder side, if you see, again, if you look into the flow initiator, we've called the collect signatures flow, right? So the counterparty will, in response to the collect signature flow, it will call this particular section where you can also, at the same time, so party B is going to run the contract on its side, but at the same time, it can perform certain additional checks, and which can go as a part of the check transaction. Again, if you look into the initiator, we have called something called as the finality flow. So in the responder side, in response to finality flow, the responder will call the receive finality flow, where after checking for double spend, the receive finality flow will simply receive the token state to be saved on its database. So this is on a very high level what this flow is doing. So quickly again, what this flow is doing is we're going to run this flow from party A's terminal. Party A terminal is going to issue a token from party A to party B. Party A will first create the transaction proposal. The transaction proposal will be an issuance transaction. This issuance transaction will issue a token from party A to party B. For that, we'll have to create a token state, which is going to be an output state. So we'll add this output state to the transaction builder. We'll also add the command to the transaction builder specifying the intent. The intent will be a token issuance. We'll also specify who all the signers would be. Once we've specified the signers, we'll go on and we'll first verify that whether the transaction is valid or not by running it against the set of rules which we've defined in the contract. Once all the contract rules pass, we ourselves, that is party A himself, will first sign the transaction. Once he signs the transaction, he will send this partially signed transaction to the counterparty, to party B for signing. Party B will do the same thing. Party B, in the responder side, he will receive the partially signed transaction. He will also verify the contract on his side. He can perform additional checks. And and then party B himself will sign to this partially signed transaction and send it back to party A. Once party A receives this partially signed transaction, party A will call at the end the finality flow, where we check for double spend, and then finality flow basically helps you to save this state, the token state, on party A as well as on party B side by calling the receive finality flow on the party B side. So let's do one thing. Let's go to our test class again and let's uncomment all the test cases from the flow. So I'll uncomment everything at once, do a command and /. Let's go back to our flow initiator and let's write the 3-4 steps which we just discussed. So the very first step is creating a transaction proposal, that is creating a transaction builder. Now, I mentioned to you that the transaction builder, that in the finality flow, we send the transaction to a notary for checking for double spend. So let's grab hold of the notary. So if you look at the very first line, what this first line is doing is, it is grabbing hold of the notary. Once we have the notary, let's assign it to this particular transaction. Also, one thing to mention is that this token issue flow initiator, it extends flow logic. So similar to how to define a particular token state in Corda, token state, we had implemented it with the contract state interface. To define a contract, we'd implemented it against the contract interface. So similarly, if you have to define a flow, you have to extend it with the flow logic class, which tells Corda that this is a particular flow. Okay, so coming back, we have the notary with us. We have the issuer with us. So now what issuer is, so get our identity basically returns you a party class. Now, since this flow we are going to run from party A side, so get our identity will return party A to me. So our issuer will be party A class. Now we have built a transaction builder. Now let's add token state to it. To add token state to it, let's first create a token state class. So let's add the issuer, owner, and the amount. So here, if you see, we have the issuer, owner, and the amount. So, so the issuer is basically party A, which we are getting from get our identity, and the owner and the amount are the values which we will specify when we run the flow from the command line. So now we have a token state ready. Now let's add the token state to our transaction proposal. So transaction builder dot add output state token state. So what this does is basically we are saying that this is my transaction proposal and I want it to have one output state because this is going to be my token issuance tokens issuance transaction. So once I've added the state, let's also add the command, or let's specify the intent of this particular transaction. So my command will be new token contract dot commands dot issue. So I also have to specify who the signers would be for this particular transaction or for this particular command. So my signers would be issuer. So I get the issuer zoning key for signing and um, issuer, and it will be owner as well. Okay. So that's it. These three things are required. So we've built the transaction proposal. We've said that this is going to be a token issuance for a tokens issuance command. And this command, if you go and look into the token contract, we've specified certain commands. So this is how you can specify a particular command. So our command is issue command. And the third thing is we've specified the signers and we've also added an output state. Okay, so that's about it from the flow perspective. So let's go and run our test cases. So let's run this test case. Once the test case passes, what we are going to do is we are going to deploy, or we are going to first deploy a local Corda network, and we are going to deploy party A, party B, party C nodes onto this particular local Corda network. And then we'll issue a token, or we'll issue a flow from party A side to party B side. That is, we'll issue a token from party A to party B, and then we'll verify certain things. I'll also show you how basically to deploy your Corda node. So the test case is running. Considering we are out of time, I think I'll take another 5 to 7 minutes and then we should be done. Okay, so just do one thing. All of you go to the token state and uncomment the @ belongs to contract. So this basically specifies, so I'm going to run the test case again. So this basically specifies that this particular state should be governed against this particular contract. So this is an annotation which we just forgot to uncomment. So just uncomment that annotation and rerun your flow test. The test case are running. Yeah. So all the test cases have passed. So we can safely now deploy all our nodes. So let's do one thing. Go to the settings tab and click on command palette and run this first command, which is Corda deploy nodes. So when you run this command, what exactly happens is, so if you look over here, we have something called as build.gradle. In this build.gradle, we have specified, we have a task called as deploy nodes task. Now this task basically what it does is, we've specified certain nodes which have to be deployed locally onto our local network. and these are the configurations of these particular nodes. So basically what you can do is you can basically specify you can specify the configurations of what nodes you want to deploy locally in build.gradle. So if you see over here, we are going to deploy party A, party B, party C, and notary as well. So these are the different configurations which you can specify in build.gradle. So once we have deployed that, again go to settings and command palette. You can also do a shift command and P. And then now once we've deployed it, what we'll do is now let's run our Corda nodes. Okay, or let's deploy a local network and let's run these nodes. So type this command. So what this will do is basically in the drop down, you would be able to see these 4 nodes which are starting. So you'll be able to see notary party A, party B, and party C starting. So this is a command terminal which is given to you from where you can actually interact with your nodes. So here you can see party C is starting. Here party A is starting. So party A has already started and party B has already started as well. So now let's do one thing. Let's run our flow from party A terminal, or rather let's issue a token from party A to party B. Okay. So do one thing. On the command terminal, you can do a flow list. This will give you the list of flows which are available for running on this particular node. So on party A side, to run a particular flow, this is the command which I'm using. So start and followed by the flow name. So just copy the flow name and hit enter. It will show you what are the parameters which it requires. So what I'm going to do is I'm going to copy the parameters. So we are going to run this flow on party A side, and this flow says that tell me who the owner of the token will be, and tell me what amount you want to issue to this particular owner, to this particular party B. So party A says that I want to issue an amount of 10 to party B. So when I hit this, the flow has started and it is now in the collect signatures flow. And then the flow says that the flow is completed. So now let's verify that whether the token state has been issued from party A to party B. To do this, fire the run command. Let me paste this on the chat channel so that you guys can copy it for you to run it. So now now let's verify whether the token state has been issued. To do that, hit the run command and hit enter. It will give you all the set of commands which you can fire using run. So copy this one, which is the vault query. So using vault query, basically what we are going to do is we are going to fire or hit the database and check whether token state has been saved on our database or not. So copy the vault query and also copy the contract state type. So this is the parameter which it takes, and the contract state type specify the full path to your particular state, which is our token state. So we specify the full path to token state. So when I hit enter onto party A, you would see that a particular state has been saved or recorded in the database. And this is the issuer. Issuer was party A and the owner is party B. And amount of 10 has been issued from party A to party B. Now, if we run this similar command on party B side, then you should see a similar view of the database on party B side as well. Okay, so this is the blockchain guarantee which Corda gives you, where party A and party B now have a similar view of the data, and you really don't have to get into any reconciliation or any other stuff to make sure that what you see is what I see. Now, if I go to party C terminal and type in the same command, you should see that you don't really have anything into its database. So though party A, B, C, though all of them are on the same network, only party A and party B have a similar view or have an idea about this particular transaction, or rather they have a view or they have this particular state data saved onto the database. Party C being within the same network, being on the same network, it doesn't even have any idea that such a transaction took place, and it doesn't have any idea about the token state. So yeah, so that's about it from our side today. And you guys very well, you try this Corda app, try running this Corda app, and yeah. So so coming up next is our July workshop. In our July workshop calendar, the next workshop will be hosting it on July 30th. It will be on the same time, Thursday, same day, 2 p.m. India time. So make sure you join us. It's going to be a very exciting and interesting topic. Also, quickly to comment again. Yeah, also quickly, you can visit the Slack channel, and you can feel free to ask us any question on Slack. Okay, let me share. Yeah. So so do visit the free training site as mentioned by Ashutosh. Also, if you have any questions, feel free to chat with us or contact us on Slack. Also, do subscribe on the YouTube channel so that you can get latest updates of our workshops every month. And also feel free to visit the docs channels where you have whole list of documentation available. So as of now, considering the time, I'm going to say goodbye to all of you and hope to catch up with you for the next workshop on July 30th. Thank you all. Thank you all for all the time, and hope to catch up with you soon. Yeah. Bye.